Welcome to Chapter 1, Section 4, Properties of Numbers. So starting off, once again, we need some vocabulary. So one of our vocabulary words here is properties. And in algebra, what properties means is they are statements that are true for any number. So these next two are examples of properties. So here we have the commutative property of addition and multiplication. And so that means the order in which numbers are added or multiplied does not change the sum or product. So if I do 3 plus 5, that's the same thing as 5 plus 3. I can commute, right, and move the numbers around, but it doesn't matter what order they're in, you'll always get the same answer. And it's the same for multiplication. 3 times 5 then, let's just turn that into a multiplication, is the same thing as 5 times 3. Okay, so commutative property, you commute to school, they move around. Then there's the associative property of addition and multiplication. What that says is the way in which numbers are grouped when added or multiplied does not change the sum or product. So associative, who you associate with. So say we have 3 plus 5 plus 2, and we add 3 and 5 first to get 8 plus 2, which is 10. Or say our 3 plus 5 plus 2 again, but we add 5 and 2 first to get us 3 plus 7, which is also 10. So in multiplication or addition, the order that you do it in, like the ones that you group together, doesn't matter. So 3 plus 5 plus 2 is the same thing as 5 plus 2 plus 3. Who you associate with, the associative property. Our additive identity means like who you are. So when 0 is added to any number, the sum is that number. So your identity, who you are, the additive identity is 0 because it keeps the number the same. 3 plus its additive identity doesn't change itself, so it's still 3. Our multiplicative identity still keeps our number the same. So in this case, our multiplicative identity is 1. I guess in all cases, the multiplicative identity is 1. Because if our number is 3, we want it to equal 3, so the number that you multiply 3 by to equal 3 is 1. It keeps the same. It doesn't change who you are. It keeps your identity. Our multiplicative property of 0 states that when any number is multiplied by 0, the product is 0. So 3 times 0 equals 0. 132 times 0 equals 0. So the multiplicative property of 0 says anything multiplied by 0 equals 0. And then a counterexample is an example that proves a statement is not true. So I could say, let's think. You can subtract a number in any order and still get the same answer. So if I do 8 minus 2, that gets me 6. Since I was saying that you can subtract your numbers in any order, that would have to mean 2 minus 8 equals 6. And is that true? No. So there's my counterexample. It proved that statement that I had said to be false. So what we need to do here is answer the following questions. And if it is not true, give a counterexample. So we want to know if the division of whole numbers is associative. So what we're going to have to do is we're just going to have to try it. And what if the associative property says is what you associate with. So we'll do 15 divided by 5 divided by 3. And we're going to do 15 divided by 5 first. 15 divided by 5 is 3. And 3 divided by 3 equals 1. So if this is associative, we should be able to do 15 divided by 5 divided by 3, but do our 5 divided by 3 first. 5 divided by 3 is a wonky number, right? 3 goes into 5 one time, and there's 2/3 left. And right away I can tell you that 15 divided by 1 and 2/3 does not equal 1. So we can just put does not equal 1, and boom, there's our counterexample. Is the subtraction of decimals associative? So what we'd have to do is have 1.5 minus 0.5 minus 0.2. Okay, our associative, we'll associate the first two together first. So 1.5 minus 0.5 equals 1 minus 0.2 will get us 0.8. Now let's see over here. Does that equal 1.5 minus 0.5 minus 0.2? Sorry, I'm getting crunchy over here. And we're going to do our 0.5 minus 0.2 first. So 0.5 minus 0.2 equals 0.3. 1.5 minus 0.3 equals 1.2. So is subtraction of decimals associative? Is 0.8 the same thing as 1.2? No. So boom, here's our counterexample proving that not to be true. Now we need to name the properties shown by each statement. So our properties are these again up here. The commutative property, the associative property, the additive identity, multiplicative identity, the multiplicative property of 0, and those are our 5 properties. So here we've got 4 plus a plus 3 equals a plus 3 plus 4. So I see there's parentheses there, so that makes me want to think the associative property. We're associating different things. But looking at that, a plus 3 is what's in the parentheses both times. So it can't be associative. But because they changed their order, they commuted, they moved, this one's the commutative property. I'm just going to put commutative. Here we have 1 times 3c equals 3c. Anything multiplied by 1 equals itself. It's identity. And since it's multiplication, it's the multiplicative identity. Now I want you to try. So you pause, check, and then compare with what I get. So here's our identity. Because anything plus 0 equals itself. It's our identity. Here, our numbers are in a different order. It's the commutative property. Here we've got our parentheses, different things in the parentheses each time, but the order is the same. So our associative. And then a number times 1 equals itself. That's our multiplicative identity. Be sure to ask questions if you are confused here, and I will come and help you the best that I can. Our vocabulary, again, simplify. So that's performing all the possible operations. You solve and you solve and you solve and you solve until you can't solve anymore, so you get an answer. Any deductive reasoning is using facts, properties, or rules to reach a valid conclusion. So here, to simplify each expression, we've got, in parentheses, 3 plus e plus 7. So I'm going to use the commutative property to change that around a little bit. And I'm going to switch the e and the 7. So I'm going to keep 3 plus 7 plus e. I know 3 plus 7 is 10, so I get 10 plus e. And then do I know what e means? No. So 10 plus e is my simplified expression. Here, 8 times x times 5. Once again, commutative property. Going to move that 8 in where the x is and move the x where the 8 is. So we're going to have x times 8 times 5. 8 times 5 is 40. And it shows us x times 40. And to make that even better, if you have a number being multiplied by a variable, you can just throw that variable right onto the end of your number. So our answer here is actually 40x. Because a number with a variable behind it means multiplication. So that tells us 40 times x. Here I can go, we have a plus 0. Plus 0 is the additive identity. So anything plus 0 equals itself. So right away I can break down that 0 plus q to be just q. And then can I add a number with a variable? No, because I don't know what that variable stands for. So there's my simplified expression. And finally here, 4 times 8 times 0. Let's remember, any number times 0, the multiplicative property of 0, equals 0. So 8 times 0 is 0. 4 times 0 is 0. So there is our simplified expression. Now I want you to go ahead and try and check and see what you end up with. And I'm just going to throw in the answers here for you. So if you're confused and you need some help, make sure you raise your hand and I can come explain to you. 120z. 31 plus w. 0. And 28 plus